Hi, I'm Mark Burns, Marketing Manager for the Application Equipment with Case IH, and newly launched today. We're talking a lot about the new 40 Series Patriot sprayers that fill out the application equipment business. Taking those mid-size sprayers in that 800 and 1,000 gallon segment and taking them to that SCR only Tier 4 emissions compliance. Seeing about a 14% horsepower increase in that 800 gallon size, going from 220 horsepower rated to 250 horsepower, and then in that 1,000 gallon size going from 250 horsepower rated up to 285. Both about a 14% horsepower increase. Really following the Patriot DNA of agronomic design advantages of cab forward rear engine configuration, boom suspension and chassis suspension for level boom and stable application, but then really focusing on what's important as far as spray technology. Having two different opportunities: the existing AIM Command spray system, which uses pulse width modulation for flow control, pump control for pressure, where we can put on a constant rate at a constant pressure over a wide speed range, so we get consistent coverage and a consistent droplet size over the entire field. Now, with the next evolution of that, AIM Command Pro is going to build off the features that we find with AIM Command and take those things to the next level, starting with individual nozzle swath control. So being able to go into those areas that we've already applied, or getting into turn rows or into contours, and being able to shut nozzles off one at a time, 20 inches at a crack, and then once we get out of those applied areas, turning them on 20 inches at a time as well. As opposed to existing technology today, which is going to be by boom section, which could be up to 15 feet. So we're looking at significant chemical savings when it comes to using that type of technology. And then secondly, a feature called turn compensation, where as we get into turns or contours, the speed of that boom is going to be traveling at different speeds. Inside going much slower or even potentially backwards, and then the outside of that boom traveling significantly faster, where the only true application rate is going to be in the center of the vehicle. By using this turn compensation, we're going to minimize that over application that's going to happen on the inside boom, the under application that happens on the outside. By adjusting that pulse width, we're going to put the correct amount of flow through each individual nozzle as we go progressively across the length of the boom. Really, it's about making the most or best use of the chemical that we see. When you look at especially something along the lines of individual nozzle control, is it comes to plant damage from over application. It also comes from input cost savings by putting more chemical on than we absolutely really needed to. And then the same thing when you get into that turn compensation, the over application on the inside, so we're having crop damage, we're putting on more chemical than we actually should be. The outside of that boom being less chemical being put on because of the speed of the boom, so we get reduced coverage, but then there is also the potential for weed resistance because of that. So really a couple of factors driving that.